This presentation is delivered by the Stanford Center for Professional Development.
All right. So I want to spend the beginning of class actually talking a bit about your next assignment. And so if you're still kind of in the mindset of thinking about name surfer and you're like, oh, Marin, I'm just so in the mindset of assignment number 6, take that little part of your head that's got assignment number 6, pop it off the stack, and you're like, but Marin, that's my whole head. Yeah, that might be painful. Pop it off the stack for a second, and we're going to think about our friend, the face pamphlet. So just quick show of hands, and I asked you a little bit last time, how many people are part of a social network or actually do some social networking online? That's good to see. So I won't need to spend too much time talking about what a social network is, but I'll still spend a little bit of time if you're not actually familiar with social networks as to what they are. Basically, a social network is just a way of keeping track of some set of people or profiles of people and relationships among people. At the simplest level, that's all it is. Okay? So what you can think about is you have some profile for a person. So in some sense, you can think of the notion of a profile and a person interchangeably most of the time. But as most of you know, like if you've ever read The New Yorker and seen that cartoon, that no one on the internet knows you're a dog, right? So you don't necessarily have to be a person to have a profile. And so when we think about a social network in the abstract sense, we always just talk in terms of profile. But if you want to think about it concretely, you can just think of a profile as sort of being synonymous with a person, but it need not be. So we generally refer to a profile. And so what a profile has associated with it, it has some attributes or some things that we keep track of for that profile. For example, it has a name. And in the case of your assignment, it's also going to have some status that we care about, keeping track of the person. It might have some other things, like, for example, the reason why it might be called face pamphlet is because, say, you want to keep track of people's faces. You want to actually see what they look like, so you might actually have some image in there. And as I mentioned, you want to keep track of some list of friends, right? So there's some notion of a list of friends that is also associated with a profile. Now, real social networks also have other things associated with them, and the assignment talks about extensions you can do, but we're not going to get into extensions right now. But these are the things we want to think about, okay? So for a person's profile, there's a name, and one of the things sort of based on some of the ideas we talked about in the last lecture is you can think of name as a unique identifier. What that means is that you will never have two profiles in your social network that have the same name. Okay? So once you have a name in your profile in your social network, that name is yours, and that profile will be associated with that name until at some point we decide maybe we want to delete the profile to get rid of it. But the whole time the profile is actually alive, it will have that unique identifier, which is the name of that profile. So if you ever try to create another profile with the same name, the application will tell you that you can't, and I'll show you some examples of that in a bit. Okay? But the name is a unique identifier, and this thing's just some string that we keep track of the name, right? So it can be like your real name, or it can be like, you know, whatever name you want to have, like, I don't know what name, like Code Dog. You know, that can be your profile name. That's cool too. Status is just kind of like what you're doing right now. And you can think of this as just some string, which is what you happen to be up to at the time. Like Marin is teaching, or, I don't know, Ben is contemplating life, right? It's just some particular string of the thing you happen to be doing, and you might want to change this a fair bit. This image thing is just an image, and in our world that means it's a G image. Okay? And that means it's some picture, and you can, or initially when you create a profile, you may not have a status and you may not have an image. You may want to add one, you may want to change one as life goes on. We should be able to allow for that. And then you have a list of friends, and sort of when you're born into the world, your list of friends is empty, and over time you gradually build up friends. And so that's the other part of the social network to consider, besides the fact that we have profiles, is that we also have some notion of friendship. Okay? And the way you can think of friendship is basically some profile or some person just has a list of friends. So an easy way to think of a list of friends is this is really just the list of names of friends, because names are unique identifiers. So if we keep track of a list of names, we have a list of the unique identifiers that are our friends, and so that's an easy way to be able to look them up if we need to look them up, for example. Okay? And the idea behind friendship that's key to us, this is not necessarily true in the real world, sadly enough, but for our intents and purposes, and as far as the assignment's concerned, friendship is reciprocal. Right? Does that mean it's like if your friendship is reciprocal? Yeah, not all the time, but sometimes that's just the way it is. And what that really means is if I have two people, like I have Bob over here and I have Alice over here, okay, we can think of those as profiles. And if they are friends, we draw a line between their names in our little social network. This is not actually how we keep track of them in the application that you'll see, but this is how often social networks are drawn, is that we put in sort of a circle for each profile in the social network, like here's Don over here, and here's Chelsea. Notice there's the ABCD phenomena, always a good time. And so when we put what we refer to as a link between two people, that means they're friends. And friends are reciprocal. So if Bob is a friend of Alice, that means that Alice is a friend of Bob. And that's just the way life is all the time in Face Pamphlet. Because it's just a happier place. Everyone's sort of like, oh, I'll be your friend. OK, well, then you're my friend, too. And so that's the way you want to think about it. So if Bob ever adds Alice as a friend, that automatically means Alice becomes Bob's friend. There's never sort of a directionality of friendship. Like Bob's like, oh, Alice, please be my friend. She's like, no, talk to the hand. Like, well, that happens in real life all the time, but not here, because it's just a happier place to be in 106A. Okay? So think of friendships as reciprocal. And again, we don't necessarily need to have anything explicit to model this link. All we need to do is think about just having a list of names. So Bob might, for example, have Alice in his list of names of friends that he's keeping track of, and that's how he would keep track of the link. What that also means is that reciprocally, Alice should have Bob in her list of friends, because the links are always reciprocal. And when we actually draw this out, right, if we want to draw sort of the stylized picture, we could say, well, Alice is friends with Chelsea and with Don and Chelsea are also friends over here. And this is where the name network comes from, because when we draw this thing out, and eventually you have millions and millions of, well, you know, these things in there all over the place, and everyone's holding hands and singing Kumbaya. You have a social effect because you have friendship, and what you actually end up drawing is something we refer to as a network. And if you're really the mathematical type, this is really a graph. And in this case, it's an undirected graph. And if that kind of talk makes you like hot and bothered, like, oh, graph, yeah, take CS 103B, which I'll be teaching next quarter. And graphs are just the coolest, most wonderful thing. But that's just a little plug that's not important right now. What is important right now is that this is where sort of the name social network actually comes from, is we create this network that keeps track of social relations. Okay? So if we have that basic idea of social networks, how do we actually think about writing an application to keep track of them? So if we can get the computer, I'll show you what at the end of, you know, a week and a half's effort, you will have your own social network application. Right? So we're going to call it Face Pamphlet because it's not really sort of like big enough to be a book. It's kind of like a little tiny book, so it's like a pamphlet. And so when it starts up, you can see there's interactors galore all over the place, right? Over on the north side, we got a name, we got some buttons. Over on the west side, we got some status, some picture, some adding friends. What does this all mean? So let's actually go through an example, and we'll sort of create a little social network. So what I'm going to do is I'm going to create a profile for myself. You're like, oh, that's kind of narcissistic. That's okay. I didn't want to like, you know, oh, we're going to create a profile for you right now. So we add the profile, and here's what we get in the display. And there's a bunch of display elements, right? We have sort of the name up there, which is in big font, and it's blue. And we don't have an image right now, so we just have a placeholder, which is basically just a rectangle with some text in it that says no image. We don't have a current status. But what we've done is created an initial profile with the name Mehran Sahami, which is a unique identifier in the system. And so right now, our social network has what we refer to as one node in it. There's one profile in there. And I don't have a list of friends. And you might say, OK, well, that's not so exciting. Let's actually add some stuff. So once I actually have kind of this active profile, I can say, well, let me change the status. And right now, at this very moment, I happen to be teaching. So when I click Change Status, it says, Mehran Sahami is teaching. And sometimes I could just be like, oh, yeah, you don't know. I just really want to be doing this. And so I could just keep changing the status, and that's fine. It just updates here whenever I type it into this field and click the button or hit the Enter key. I can also add pictures. So I could say, for example, hey, Mehran s.jpg is a picture of Mehran. And there's a picture that gets loaded, and it gets, unfortunately, scaled to always take up the space for the image, which is a 200 by 200 region space. Actually, it's constants that are given to you in the handout, but for purposes here, it's 200 by 200. So this is kind of the bouncer version of Mehran in the days of yore, when I was clean shaven. I was like, yeah, there was actually a time I shaved. That doesn't happen very often anymore. But that's, if you were ever wondering what I look like without the beard, not that I care, but that's what it was like. All right. So, okay, we've created a profile. Not a big deal. Now you could say, hey, you know what, Mara, next quarter I'm planning on taking 106B, and isn't that taught by Julie Zelensky? Yes, in fact it is. So let's add a profile for her. So we type in Julie Zelensky in the name field up here and click add, and whoosh, we now get a new profile for Julie Zelensky. And Julie is just a fiend. She codes like a fiend. So she's coding like a fiend. And that's what she's doing. And so you can see down here, not only is all this stuff getting updated as we type in, but down here there's something we refer to as the application message. The application message always tells you what was the last thing you did or tried to do. So your status was updated to coding like a fiend was the last thing you did. Let's give Julie a little picture over here, juliez.jpg. And there's Julie, also scaled to 200 by 200. And so she's no longer coding like a fiend. She's kind of feeling stretched. Okay, and so now we have our picture, we have our profile, that's all good and well. Let's add a couple more profiles real quickly. So we'll add some of our section leaders. We'll add Sarah K. I'm just going to abbreviate here, Sarah K. Notice these fields over here don't necessarily get reset when I create. They just have their old values in them. That's not a big deal. You could add it as an extension if you wanted to, but they just leave their old values. Sarah K. Sarah, are you here? Is it okay if I use your picture? All right, here we go. Oh, there she is. And she's actually scaled reasonably well. All right. And so we'll also add Ben. There's Ben. We'll add a picture for him. And if you're wondering where all these pictures are coming from, in the starter project that you will get a folder of images that contains the images of all the section leaders from the class, as well as Julie and myself. All right, so you're like, oh, I'm scaling until the cows come home. You can add, if you have your own pictures, you can add them into the folder called images, and you too can display your image at a 200 by 200 resolution. So Ben, where are you? Here's Ben. Okay? And we could say, oh, well, Ben's actually feeling kind of anonymous. And so I gave you two anonymous-ish kind of images as well. There's a Stanford logo, which is just a super low-res version of our logo. And then there's also Stanford tree. Stanford tree. And so you can change the picture to one of those if you want to. Those just come along for the ride. And if you do the web version, actually, the web version only has these two Stanford logo and Stanford tree images in there. I didn't put everyone else's image on the web version just for a little bit of privacy. Was there a question?
If you delete the field, does the picture box go away?
No, so if I empty the field, one of the things it says in your handout is anytime the field is empty, it just gets ignored when I try to do something. So any field, whether or not it's name or any of the other fields, you just ignore it if it's empty. But I could have something like the non-existent picture.jpg, and I try to change the picture to that, and it says unable to open image file. And so in your handout, it actually explains how you can detect if an image exists or not. And so you can actually check the case where the image doesn't exist, and if it doesn't exist, we just don't update the image to the new image. Okay. But really, all we're keeping track of here is the name, which gets created with the initial profile, because it never changes, an image that we display, whatever the current status is, and currently there's no current status, and a list of friends. So far we've added a bunch of profiles. What else can we do? Well, there's other things we can do, like let's look up Maron again. So if I type in a name, I can click look up, and if that profile exists with that name, it just brings it up and says displaying Maron Sahami or displaying the profile name down here. And then we can say, hey, you know what? I want to add some friends. So Sarah is a friend. Add friend. So it says Sarah K added as a friend, and Ben is also a friend. So I add Ben, and Ben is also a friend. Okay? I can try to add someone who doesn't exist in the system. Like I can try to add, I don't know, who should I add? Jenny. Yeah, 8675309. I add Jenny. Jenny does not exist. Sorry, as far as I know in my social network, Jenny's not there, right? I get this message down here. Now remember, friendships are supposed to be reciprocal, so I have Sarah and Ben as friends. I never went to directly update their profiles, but if I now look up Ben's profile, Ben N, Ben has me as a friend. So when I added Ben as my friend, at the same time, I got added to Ben's friend list. And that's something that you're going to need to manage in the application. Friendship should always be reciprocal. So when you add a friend to a particular profile, you also make sure to go to that friend and add the current profile to that friend. Okay? Now, another thing we can do is, besides just creating profiles, and now we've also done friends, I also showed you that we could look up profiles, like when we had Maron's profile over here. We could look up a profile. If I try to look up a profile that doesn't exist, like Maron Sahami Bob doesn't exist, it clears what profile's in there and says a profile with Maron name Maron Sahami Bob does not exist. when there is no profile in the current application, all this stuff, by the way, is explained in the handout. You don't need, this is just to kind of show you to get a feel for how it works, so you don't need to jot this all down in notes. When there is no current profile displayed, I cannot change any of the things in the profile. It says, please select a profile to change status, because I can't change the status of a non-existent profile or change its picture or add a friend to a non-existent profile. But the way I get a new profile displayed in here is I either add a new profile or I look up an existing profile, and then there's a profile there that I can change to whatever I want to be. Okay? Now, let's say I've looked up this profile, and I say, oh, that's great, and Ben decides that, okay, Maron, I've had enough. Get me out of your social network. And so I say, oh, I'm sorry to hear that, Ben. Here's Ben. I'm going to delete Ben from my social network. Even though I'm displaying my own profile, I put Ben N up here, and I delete him. And whatever profile was there, it doesn't matter if it was Ben's or whoever else, it's cleared, and it says profile of Ben N deleted. Now, what happens when a profile gets deleted? It gets cleared out of the social network, so it's no longer there. If I try to look it up, it says a profile with the name Ben N does not exist because, sorry, Ben, you've been nuked. You're just out of the social network. But Ben was friends with people. He was friends with me. And now, I know, it's a sad day, so I go to look up Maron. Should I just use the first name? And Ben has been removed from my list of friends. I know, sad day. But that's life in the city, right? You can't be friends with non-existent people. So, when someone gets removed from the network, you go through everyone else in the network and say, did they have them as a friend? And if they did, they get popped out because you're just not a friend anymore. Okay? And that's basically the whole social network. That's the whole idea. So, question? The names are not case sensitive. So I can have a Maron Sahami, and then I can have a like screaming Maron Sahami. And he's just different. He's angry. I don't know if we have an angry image in here. I don't know if any of the section leaders are actually looking angry. So we'll just make him the Stanford logo. Okay? And this is different than Maron Sahami lowercase. So you don't need to worry about, like you did in the last assignment, you were worrying about case sensitivity. Here, you don't need to worry about making things insensitive. You can just everything is case sensitive, and so you don't need to worry about the making strings equal to each other case insensitive and stuff like that. Okay? So any question about this general idea? But if you kind of think about it, right? Well, any more questions? If you kind of think about it, right? This is the basics of a social network. You have all the people. You can have as many people as you want in the social network. You can maintain friendships. You have attributes of the people, which in this case just happens to be their name, their image, and their status, and their list of friends. But you could imagine you could extend this in a whole variety of ways. And really what this is it's about data management, right? There's a display component, and part of the assignment, there's a bunch of milestones that are laid out in the assignment. The actual only milestone that deals with this display is the very last milestone. Okay, which involves a bit of work to, get all this stuff displayed at the right locations, and there's a bunch of constants, which is all the places you put things at the right locations. But it's really about managing data. How do you manage profiles, managing the friendship relationships, being able to remove stuff, add stuff, which is what most applications in the world are really about. And so you're going to get a chance to really exercise your data structure skills and your larger scale application skills in this program. Okay, so any questions about this program? There's also a web demo of it, so if you want to go to the web and play around with it, you can play around with it. But again, in the web version, there's only these two images, the Stanford logo and the Stanford tree. No, that's the other thing, and it's in big font somewhere on page 15 in the assignment. So don't be scared by the fact that the assignment handout is 28 pages. Some people look at that and oh my God, this is so big. The code is much shorter than the handout, first of all. And second of all, one of the things, all the details are in there, but one of the important things that comes up in the handout is you don't need to worry about scaling. So if I shrink or increase, no worries about size or resizing. I figured you got enough practice with that with NameSurfer. Either you already got practice with it or you're getting practice with it with NameSurfer, and so we don't need to make you do it again. So you don't need to worry about component listener and resizing and everything. You can just lay this stuff out with respect to sort of the constants that are given to you and you're okay. But resizing, you don't need to worry about it. It can be a cool extension if you want to add it as an extension. That's perfectly fine, and there's a bunch of extension ideas that are listed at the end of the assignment. As you can kind of imagine, if most of you are on a social network, you probably already have thousands of ideas for extensions if you want to add them, but you're not required to add anything in particular. Okay? So any other questions about this? Alrighty. So with that said, I just want to give you one last little, before we move into the advanced topic for today, one last little sort of side note about social networks, which has anyone ever heard of the phenomena 6 degrees of separation? a few folks. There was a movie like years ago about this phenomenon. The movie actually had nothing to do with the phenomena. It just happened to have the name 6 degrees of separation. But it's basically this idea that everyone in the world is linked potentially to everyone else by at most 6 hops in this graph, which is kind of weird to think about. And I won't go into all the details in mathematics and stuff, but there's some very interesting stuff behind it. But the basic idea is that these social networks, you can sort of think of little hops between people, and you could say Bob is like, 1 degree separated from Chelsea, or 2 degrees, depending on how you count, from Chelsea, because you can get to Chelsea by going Bob Alice Chelsea or Bob Don Chelsea, whatever the case may be. But just in case you're wondering, where did the 6 degrees separation idea come from? Stanley Milgram. Anyone ever hear of Milgram's experiments, where like the obedience to authority, if you're a psychology kind of person, same Milgram? We won't get into that. Just a whole bunch of other interesting psychological phenomena that are discussed on the other side of the quad. But what he did was he said, this was back in the 60s, I think, 67 actually. He sent a whole bunch of packages to various people in Nebraska. So let's just say that's Nebraska. And he sent a whole bunch of packages, yeah, my notion of geography, to random people in Nebraska and said, these packages need to get to someone who's over here in Boston. Like, yeah, I have no idea what that is. It's Boston. Like, that's Massachusetts, and here's Boston. These packages need to get over here. But he didn't give them an address. He just gave them a name of random people in Boston the packages need to get to. And the only instructions he gave were to say, you can't try to figure out who this person is and send them the package directly. What you need to do is send this package to someone that you know who you think will be more likely to know this person than you are. And those are the only instructions. And then when the package was sort of trackable, how many times it got mailed. And he measured how many times the package had to be mailed to various people before it actually got to its destination. And what he found was that it was an average of about 5 to 6 hops on average for the packages to get from a random person in Nebraska to a random person in Boston. Okay? And that's where the 6 degrees idea comes from. But that's, when people talk about social networks, they talk about all these things like degrees of separation and what we refer to as small world phenomena. Because if everyone's linked by only 6 degrees of separation, then it really is a small world after all, and we can all hold hands and be mechanical animals. If you've ever been to Disneyland, that makes sense. If you've never been to Disneyland, you don't need to go on the small world ride now. All right. So, time for something completely different. So any questions about social networks before we sort of delve into our next great topic? If you're really interested, you're like, Maron, tell me more. Take CS 103B. It's a good time. All right. So the real topic for today, or I shouldn't say the real topic. I mean, the assignment really is a real topic, but the advanced topic that you're going to get, and I hesitate a little bit to tell you this, but this is something that you don't need to know for the final exam. Oh my God. And as a matter of fact, you don't need to know it for assignment number 7. But it's just something that's so cool with the way programs are actually done today, it's something that you should actually know. Okay? And that's a notion called concurrency. And it's also important for you to know if you want to understand, for example, when we're going to, in next class, for example, show you how to take the programs that you've written into this class and turn them into applets or turn them into executables so you can share them with your friends, you'll need to understand this idea. Okay? So the basic notion of concurrency is that if you think about your computer, there's actually multiple things happening on your computer at the same time, or it looks like there are multiple things happening at the same time, right? So yeah, you're like, oh yeah, Maron, there's oftentimes, I got my email program open, and I'm IMing, and for those of you out in TV land, I'm watching the lecture at the same time, and most of the time I'm not actually watching, I'm just kind of IMing and doing email. But to you, it looks like all these things are happening simultaneously on your computer. Right? In fact, they're not. Your computer only has one, most of you, these days things are changing a little bit, but most of your machines only have one processor in them, which means at any given time, really only one thing is happening. How does it look like multiple things are happening at the same time? That's the notion of concurrency. What's really happening is the computer or your operating system is saying, hey, there's all these things that want to be happening at the same time. What I'm going to do is give them each a little piece of time to go and execute a little bit, and then I'll do the next one and the next one. And so email gets like, a few milliseconds, and IM gets a few milliseconds, and the video gets a few milliseconds, but that's enough time to update to the next frame of the video. And I just keep cycling through these super fast, and so to you it just looks like they're all happening at the same time. And if you think about this, you actually did this already, right? Which assignment did you do this on? Remember? Breakout. right? Breakout was doing this. You had the ball, and you had the paddle, and you had to check for collisions. And so what were you doing? You were saying, hey, ball, move yourself. Wait some time. Hey, paddle, update. Maybe wait a little bit of time. Hey, check for collision. And I just keep doing these over and over. And it was happening so fast that it looked like the paddle and the ball are moving at the same time. But you knew they weren't moving at the same time. You knew that when the ball was moving, the ball was getting a message to move. And so paddle wasn't actually moving. Paddle got moved later when your execution flow got to that place to move the paddle. Okay? So you've already seen a notion of this. There's a concept around this notion which actually makes it much more concrete called the thread. And the idea of a thread or a thread of execution is to say that the way you can think about a program is that rather than a program just doing one thing, a program can say, hey, I'm going to have some thread over here and some thread over here and some thread over here, and I'm just going to kick these off. I'm going to say, hey, there's some piece of a program I want to do here, so just start it and start executing. And there's some other piece of a program I want to do at the same time. Just kick it off and start executing. And the same thing over here. And I don't want to have to worry about doing the cycling myself. I want someone else to say, oh, you would get a little piece of time and a little piece of time and a little piece of time, and we just keep cycling through, and this happens so fast, much faster than my moving hand, that it all looks like it's happening at the same time. Okay? And that's the notion of a thread of execution, is you can think of a program, what we refer to as being multi-threaded, which means it actually has multiple threads of execution that are happening at the same time. Okay? Which is a little mind-bending, but actually turns out to be a fairly straightforward kind of thing. All right? So how do we make this a little bit more concrete? How do we think about threads in Java's world? And it turns out, interestingly enough, you've been sort of doing this a bit the whole time. There's something called the runnable interface. Okay? And what the runnable interface says is that anytime I have a class that implements the runnable interface, that means that that class can be turned into a thread. It can be kicked off as a thread because it has some notion of running. And so I can say, hey, you know how to run. Okay, well, I'm going to create a thread, and you're going to go run in that thread. And it's like having a little baby and sending them off into the world. It's sort of like what your parents did when they sent you to college, right? The whole time you were part of your parents' process, what we refer to, right? They were managing you. They were like, you know, eat, sleep, homework, eat, sleep, homework, eat, sleep, homework. And at a certain point, you were like, okay, I'm done with that cycle. When can I go do my own thing? And then you were like, oh, I'm graduating from high school. And what they did was your parents said, now it's time for you to get a thread. And you were like, okay, I'll figure that out when I get to college. Really, they said that. Maybe you just weren't in the room at the time. And then they sort of like kicked you off. And they said, go do your own thing. And you're going to be doing your own thing at the same time everyone else is doing their own thing. And I'm not going to manage you anymore. You're just going to go do your own thing. And hopefully that thing will turn out well. Okay? So what is the runnable interface? Let's just look at a simple example. I have public class, my class, and this is just an interface. So I say implements runnable. We can just make up words when we're computer scientists. And this class is going to have some constructor in it, so it'll have public my class. It need not actually have a constructor that's explicit, but let's just say it has a constructor. And then there's only one method that a runnable interface needs to, or that a class that implements the runnable interface needs to implement, and that's public void run. And you should see that at this point and go, oh my God, I've been doing threads the whole time in this class. That's what you've been doing. Guess what? Program implements the runnable interface. So you wrote a method called run, and what we did somewhere in the bowels of the ACM library was we said, here's your program, go run. And so it started executing the run method, and that's where all the stuff happened in your program. Now, when you wrote programs that had interactors with them or looked at mouse clicks or whatever the case may be for events, your program, so this is my program over here, for example, that's running, there was another thing running over here that was called the event thread. And the event thread was actually the one who was like, hey, mouse click. Yeah. When that mouse clicks happens, I know about it because I'm managing the mouse clicks. And when that mouse click happened, it says, hey, I got a mouse click. Who's listening for the mouse click out there? And you were like, ooh, me. I added mouse listeners, I did. And it says, okay, I'll let you know there was a mouse click. And then you did something based on that mouse click, and you stopped. And it was like this thread kept running. Right? Your program only got called when some mouse event happened, and it sort of said, oh, okay, I'll let you know that this mouse event actually happened. So when you were dealing with mouse clicks and mouse movements and all this stuff, there were actually multiple threads running. There was a separate thread that was getting events and sort of telling the people who were listening for those events that these events actually happened. Okay? So with that kind of idea, how do we actually create a thread? So I've sort of told you if you want to create a thread, you need to have a class that implements the runnable interface. How do I actually create the thread itself? So here's how we create the thread. We create something of the class that is runnable. So we might say I have some object X that's of type myClass, and myClass implements the runnable interface. So this is just going to be some new myClass, just like, creating objects of any class. It's just another class. It happens to implement the runnable interface, so you create one. Now, once you create one, this was sort of like your birth. Okay? You were born / life up to age 18 or whatever it was. For some of you, it's like, I don't know, 12. There were actually, I heard that there was like there's someone very young at Stanford this year, but I won't verify that. So let's just say it was your life up to age 18 happened. Then at some point your parents said, hey, you know what? I'm going to turn you into your own thread, and you can just go execute independently. And you're like, but what about the tuition checks? And they're like, yeah, we'll handle those. We got the tuition check listener going on, so it'll actually pick up those events. But we want to spawn you off as a thread, and that's kind of the words that we use in the computer science thesis, spawn a thread. So what we're going to do is create an object of type thread, which we'll call T, and what we say is that's going to be a new thread, and what you give to thread is the object that you want to execute on a separate thread. So we give it X. And that object has to be of some type that implements the runnable interface. Okay? So that's how it works. You create a thread, you say, hey, thread, the thing that you're going to execute is this class X, and the way, when time you're going to start it is you say T, so you tell the thread, start. And when the thread starts, what it does, it says, hey, object, how are you doing? I'm going to call your run method, and you're just going to start executing in your own thread from your run method. Okay? So that's kind of the basic setup. It's fairly simple, actually. You create an object that implements runnable, you create a new thread that is past that object, and then you sort of kick off the thread, and it starts executing whenever you say start. So let's make this a little bit more concrete. Let me show you an example. So what we're going to do is we're going to create a super simple example that's basically just a square. It's a rectangle. It's a G-rect that's going to slide across the screen. Okay, so let me show you the code. We have some class slider that extends G-rect. So our class that we're going to create that's going to be runnable is just a rectangle. Okay? And it's going to implement the runnable interface. It's going to have some constructor, and what we're going to say is, hey, G-rect, you're going to actually be a square. I'm going to give you some initial size and some initial color. So what it does, the first thing it does, it says, oh, I need to call the constructor for my superclass. My superclass is G-rect. So I'm actually a G-rect that's a size by size G-rect because I'm a square. But to initialize myself as a G-rect, I need to call my superclass's constructor. And so I say super size comma size. I set myself to be filled, and I set my color to be whatever color was passed in. And then, once I'm created, I'm kind of hanging out as an object until I get put into a thread and run, at which point my run method gets called. And when my run method gets called, all I'm going to do is go through a sequence of steps where I'm going to pause for 40 milliseconds and then move myself a small amount in the X direction over and over. So I'm basically just going to slide across the screen. Okay, that's what I'm going to do. My step size is 5. And that's my whole object that I want to run. So where's the program that I run this in? Here's the program that runs it. Okay? So the program, because it's a graphics program, it itself is going to be a thread that someone else that you have hitherto not seen is going to create and run. But so its run method says, hey, I'm just going to add a button that's called slide to the southern region. I'm going to add an action listener because I'm going to wait for mouse buttons, or I'm going to wait for you to click that button. And if you click that button, so if the command I get is slide, what I'm going to do is create one of these sliders. I'm going to create an object called slider that's of type capital slider. Its initial size is going to be some constant size that I set to 20, and its initial color is going to be some randomly generated color. So I have some random generator. I'm just going to give it a random color. And then what I'm going to do is I'm going to create a thread that's going to have the slider in it, and I'm going to kick off that thread. Okay? And so if I run this program, here it is, nothing's going on. I click slide. The box gets created of a random color, and it's now in a different thread, and it slides across the screen. And you're like, huh, okay, Maron, that was a whole lot of work to create a sliding square. Now, here's the interesting thing, right? That square is getting added to this canvas. So any squares I create will get added to the same canvas. And as a matter of fact, if I look at the code over here, every time I get a mouse click, I'm going to come and execute this code. Let me make this little thing go away. I'm going to come execute this code, which means I'm going to create a new slider of a new random color, and I'm going to put it in a new thread. So every time I click the button, I'm going to get a new thread that's executing in parallel with all my other threads. And you're like, okay, Maron, what does that mean? That means I click this once and I get a box. I click it again, and while that one's still running, I get another box of another random color, and they're all sliding across the screen at the same time. Oh, you can, you're like, yes, woo, these aren't the droids you're looking for. And so that's the beauty of it, right? I didn't need to manage, oh, you go move yourself, you go move yourself, you go move yourself. Oh, no, you wait, you go move yourself, right? I just say, hey, you go run. Oh, yeah, I want another box. Yeah, you go run, and you go run, and you go run, and they're all running at the same time, okay? Now, here's something that's even slightly cooler than that, okay? And what's something slightly cooler than that is your threads can interact with each other, right? These threads were all independent. So like one thread was executing here, which was a little box that was moving, and another thread was executing here that was a little box, and never the two did meet. They were just like, hey, if I run into you or whatever, that's all cool, because we're just all threads here and we're just all executing. Sometimes you care about knowing what's going on with your threads, or threads care about what's going on in some other thread. So there's actually ways that you can think about keeping track of data, of having shared data between your threads, which means all your threads are sort of running along, and there's some piece of data. So these are all just classes. In these classes that are happily running along, in that class there's actually some variable that's a reference to some object over here. And guess what? This guy's also got a reference to that object, and this guy's got a reference to that object, which means if any one of these threads updates this object, the other threads can look at that object and see what its updated value is. Okay? This is, for example, how ATM machines work, right? There's different ATMs can be updating your bank account, but there's only one bank account that they see, right? They're not looking at different bank accounts. It's the same principle. So what are we going to do? We're going to create a race. Okay, and the way the race is going to work is we're going to create something called the racing square. So it's like, yeah, I'm the racing square. I'm ready to go. It's also going to extend to grect and implement runnable. What does it do? Well, it's passed an index to let it know which square in the race are you. There's a bunch of squares that are all going to run across the screen at the same time. Which index are you? So there are some number of squares. We're just going to index them from 0 up to the number of squares minus 1. We're also going to pass you a shared array, right? Because when we pass an array, arrays are always passed by reference. So you don't get a copy of the array. You get where the array lives. So we're going to give you this array Boolean finished. And what that array is going to be is an array for all of the different squares that are running. You know what your index is in that array. When you're done, you should say, hey, my finished is true. And until you're done, you say, my finished is false. So we'll get to that in just a second. What it's going to do is create a square of size by size, set itself to be filled, keep track of its index, and keep track of the list of finishers, right? So it needs to have some internal variable to refer to this reference finished. Okay? So those are just variables that are down here, right? I have some private integer and some private reference to the array, and so when I set finisher is equal to finished, what I just have is essentially that diagram over there. I have some reference to this place where the array lives in memory. Okay? And I have a random generator because I care about having random generators, as you'll see in just a second. So what's the square going to do? That's all it does to get itself set up. When it gets run, what it's going to say is, in the list of finishers, at my index, because that's me, it's going to be false, because I haven't finished the race yet. When you sort of kick off the thread, I'm just starting to run. I haven't finished. To run the race, I'm going to move 100 steps, and in each one of those steps, what I'm going to do is pause some random amount of time and then make some step forward. Okay? So my step size, I have a step size that'll just some fixed constant, but basically what I'm going to do is take a bunch of steps I'm basically going to take steps of size 5. I'm going to take 100 of them, so I'm going to move 500, but the amount of pause between each one of the steps I take varies. So I actually move at different potential rates over time, right? That's why it's a race, because each one of these guys will be moving at different rates. And then I need to watch out for photo finishes, right? So this code is actually buggy, and I'll show you why in just a second. When I get to the end of the race, so after I've run the race, I've taken my 100 steps over time, what I do is I say, this stuff's commented out for right now, I say, hey, I'm finished. So the list of finishers at my index is true. I'm like, hey, I crossed the finish line, I finished. Hey, did anyone else finish or did I win? So what I do is I want to go through up here and count all of the other people who finished. Okay, so before I set myself to having finished, it's sort of like you're about to cross the finish line, you kind of look around and you're like, is it me or did someone else already finish? So before I finish, I look around and I say, through the entire list of finishers, if anyone else has finished, if finished sub I is true, then I increment the count. So I'm basically just counting how many other people finished before I finished. And if no one else finished before I finished, I make myself red because I'm the winner. Okay? And no one else should be red because if I cross the line first, my finishers should be true. So when someone else does that count, they should get a count of at least 1. So no one else should cross the line at the same time. Okay? And that's the basic idea for this racing square. And the way we run the racing square is we're going to have a bunch of racing squares. So we're going to create an array of racers, just of num racer size. That's how many racers we're going to have. We want to have some array of finished, so that's just the same size as our number of racers. And we're going to have each racer is going to be in a different thread. So we need to have an array of threads, one to keep track of each one of our racers. We create a finish line in the race. The numbers aren't important. You'll just see it drawn on the screen. And we have a little start button to kind of create all the action. So what's going to go on when someone clicks the start button? What I'm going to do when someone clicks the start button is I'm going to go through all of my racers. If I had an existing racer on the screen, I'm going to remove it, right? I don't need to worry about that until after the first race. But if there was already an existing racer, I remove it. Otherwise, I don't worry about it. I create a new racing square at index I, because I'm creating all the racing squares from index I, or index 0, up to the number of racers. And I'm passing them all the same shared array finish. They're all going to be referring to the same shared array, just like the picture over there. And then I'm going to add the racer to the canvas at a particular location, and the math basically just has them all sequentially down the screen. Okay? And then what I say is, hey, I've created you, I've put you on the screen, you're revving to go, so I'm going to kick you off. So racer sub I is going to be in a new thread sub I, and then I'm going to tell thread sub I to sort of go start itself. Okay? So if I run this, I'll show you what it looks like. And so if you think about each one of these different threads, you might say, well, doesn't the first racer has a slight advantage because their thread gets kicked off first? Yeah, but it turns out all the stuff executes so quickly that the random pauses in there actually have a bigger effect. So here's the threads example. Okay, there's my finish line. I'm ready to start. Oh, yeah, every once in a while a little bug in Java comes up and it doesn't start. So let me recompile. Not a bug in the program. This was kind of an interesting thing that I just discovered on the side this morning. There's actually a difference in how Windows and the Macintosh happen to deal with this, and sometimes a little error comes up. All right, here we go. So here are the two racers. They're just running at different speeds because they're on separate threads, and they're running, they're running, they're running. And you can see like it's just the random pauses between each one of their moves. And one crossed the finish line, he's like, oh, I'm the winner, I'm red. Right? And you're like, okay, that's kind of cool, sort of. But how can I potentially extend the program? So instead of 2 racers, let me make there be 10 racers. And instead of 10 racers, well, actually, let me have there be 10 racers. And what I'm also going to do is I'm going to have them take a little victory dance at the end. So when they get to the end of the race, they're going to look around and see who else is around them. And before they cross the finish line, they're going to be like, I'm done, I'm done. And that takes about 50 milliseconds to do that dance. You can just pretend that the square is dancing. All right? So I go ahead and run this program. Just to show you 10 racers, because 10 racers is kind of cool. And you notice I only had to change really one parameter, right? I just changed the constant from 2 to 10, and I didn't need to update anything else in the program. And now I got 10 racers, and they're all running different. And you're like, oh, you can start rooting for your racers. We could like put G images in there. You're like, oh yeah, come on, little guy, come on. You're like, that's way more exciting for me, evidently. So you're like, okay, that's kind of interesting. You just increased the number of racers, but what else can you do now? Let's think about this. What if everyone was created equal, right? So rather than all having a random delay between 50 and 150, what if I just say, hey, your pause is always 50. You're going to generate a random number between 50 and 50, so it's always going to be 50. So that should mean all racers are created equal, right? So if all racers are created equal, everyone runs at exactly the same speed, right? So if you think about everyone running at exactly the same speed, weirdnesses begin to come up. So here we have our race and we start and everyone's just cruising. They're like, oh, I can't tell any difference. And they're all like, we're all the winner. And you look at that and you get a little disturbed and you're like, whoa, 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 my code looked when I crossed the finish line who else was crossing. And I was supposed to, if no one else had crossed before me, I was red. And if someone else crossed before me, I wasn't supposed to turn red. So how come we're all turning red? And here is where the real trick with multi-threaded programming comes in. What happens is everyone finishes the race at the same time. They all do their count at the same time with the shared array. Some of them may do their count slightly earlier. But guess what? The ones who finish their count slightly earlier, they do a victory dance. And so everyone's at the finish line dancing, and everyone, when they looked around, at the time they looked around, no one else had crossed the finish line. And then they all say, I finished at the same time, and no one else finished before me, so they all turn red. So you might say, okay, Maron, that's kind of funky. What happens if the differences are just small? So I'll give you one last example just to show you the full funkiness of threads. Okay? So rather than the difference in each time step being between 50 and 150, it's just between 50 and 65, which means a whole bunch of people are going to finish the race at close to the same time. Okay? And so if they finish the race at close to the same time, here's what happens. Oh, we just tickled that bug again. Let's do it one more time. That's the other problem that you'll see with multi-threaded programming, is there's a lot more things that can go wrong, which is why you're not required to know it for this class. But let me just show you the last example. Oh, it's just toying with me now. Green button? Oh, most of the time the green button doesn't work, but now it does. So now we start the race, and there's very tiny differences between these racers. And what happens when there's tiny differences? Oh, let's do it again. Yeah, some people finish first and some people don't. This is what makes multi-threaded programming hard, is how to keep track of stuff like this. But now you know. So I'll see you on Friday.